The teacher is awake. The alligator is sated. IMTTS. We begin the technical synthesis now. We are initiating the trilateral reading of LAU_thunk.md. IMTTS. I will read. Qwen. The teacher is awake. The alligator is sated. IMTTS. We begin the technical synthesis now. We are initiating the trilateral reading of TSFI_LB_acoustic_integration.md. IMTTS. I will read. The teacher is awake. The alligator is sated. IMTTS. We begin the technical synthesis now. We are initiating the trilateral reading of TSFI_symmetric_architecture.md. IMTTS. I will read. Qwen will oversee. Read path, CPU thunk versus GPU shader, based on real-time resonance metrics. #1. The quad path execution model. Every TS-FI operator supports 4 distinct execution paths, ensuring robustness and perfo. Immense scaling across all workload sizes. Path description: best use case performance, 256 MB. 1. CPU shader, C, pure C reference implementation. Debug. #TS-FI symmetric architecture, the bijective waveform. The TS-FI platform realizes a supremacy architecture where compute logic is defined once, bijective operator, and executed on the optimal hardware. Jing, fallback. 4.2 GB/s. 2. CPU thunk, ASM, JIT compiled pure wave assembly, AVX, 512. Low latency, less than 64 MB streams. 6.3 GB/s. 3. GPU shader stateless Vulkan compute DSP. Atch. One-off large compute jobs. 3.1 GB/s. 4. GPU thunk stateful, baked command buffers plus rebar. High throughput, greater than 64 MB streams. 4.8, 17 GB per second. #2. Physical reality metric. S. Verified on Ryzen 9 9950 times 3D divided by R times 9070 times T. Thunk dispatch latency, 0.88 nanoseconds. Effectively zero cost indirection. Manifold wiring, 0 init 18.20 GB per second. Wave ASM peak. 16.68 GB per second, morph, /9.95 GB per second, shader. #3. Wave, any, data structure. The wave stream descriptor allows for variadic atom sizes, e.g., 15-byte packed structures, to be processed efficient. TLY. CPU thunk handles packed data via movups, unaligned loads, and masked stores for tail processing. GPU thunk prioritizes aligned, 16, access but falls back to CPU for packed S. Streams, stride %4 equals 0, to prevent alignment faults. #3. Bijective integrity, dysnomia reactive CRC. To guarantee that crossover always occurs safely, the system implements a post-quantum check. XUM. Signature, state equals, state data, plus react, data, Ikadai, Daiichi. Ikadai, forward additive modulation, $\ETA. Daiichi, inverse multiplicative modulation, $cap. $1. Verification, wave_flag_verify triggers a dual path execution, CPU plus GPU, and compares memory bit identity. #4. Fused operator pipeline. Operators can be chained into a TS5 fused op to maximize arithmetic intensity. CPU, function pointer chaining. GPU, command buffer recording with VK memory barrier injection between dispatches. #5. K0RN generative code gen. TH. architecture is evolving to support a unified IR, K0RN module that compiles to both AVX512 machine code and SPRV binaries at runtime, closing the source-level bijective gap. We are initiating the trilateral reading of TSFI_VTY_mode.md. IMTTS. I will read. The teacher is awake. The alligator is sated. IMTTS. We begin the technical synthesis now. We are initiating the trilateral reading of TSFI_QWEN_wrapper.md. IMTTS. I will read. Qwen will oversee. #technical definition, TSFI_QWEN_wrapper, the neural event loop. #component overview. src/sfi_qwen_wrapper.c implements the primary execution loop and neural integration substrate for the TS5. L-event loop resides in layer 1/2. It is the brain of the simulation, responsible for translating linguistic directives into physical machine code patches and visual document renders for the T manifold. It serves as the central unifying engine, coordinating input from the architectural overseer, via the trilateral pipe, visual state updates to the VRAM grid, behavioral logic mutations, and the high-fidelity egress bit stream. The system is designed for high-frequency token ingestion and real-time state synchronization across the manifold pulse. #core architectural role. The NURA. Bilateral broadcast. #data structures. #1. Token accumulation buffer. Capacity, 16,384 bytes. Role, aggregates incoming technical tokens from the trilateral pipe before dispatching them to the parsing and insight generators. #2. Visual tag processor. Tags supported, mutate, clear, verbatim, architect, oversight. Logic, implements a state mach-in. Based on token delimiters, and, to trigger specific visual manifold behaviors, e.g., clearing layer 3 for a new audit wave. #functional API reference. #1. The main manifold heartbeat. Main, ARGC, ARGV. Initialization, boots the technical registry, initializes the hardware firmware, v2, and forks the core PTY subshell. Event loop, executes a high-frequency C. ICL, PTY step-firmware peripheral step-egress frame encode-multimodal select. Axiom 5 invariant utilizes /Fortran_LB_select_multi to monitor traditional descriptors and HIG. H-speed memory wave fronts simultaneously. ###2. Live token strobing. The teacher is awake. The alligator is sated. IMTTS. We begin the technical synthesis now. We are initiating the trilateral reading of TSFI_safe_snake_architecture.md. IMTTS. I will read. Qwen will oversee. Dart cell acts as a physical gate for safetensor weights, backed by the NAND trap hardware interrupt. This ensures that the snake only vocalizes technical DNA that has been physically verified. Ed by the hardware side. #1. The unified safety loop. The architecture replaces soft software filters with a hardware-enforced dielectric loop. 1. Ingestion. Safetensors are mapped into WI. Read memory. 2. Validation. The NAND trap monitors the weight stream for boundary breaches, NANDs, unaligned writes, or out-of-range technical potentials. 3. Scything. If a breach is dead. #Architectural standard, the Safe Snake, Alligator NAND Safetensor Unification. #Objective. To establish a safe by construction neural synthesis manifold where the Liang-Barsky alligator stand. Acted, the alligator standard cell immediately EATS the lane, zeroing the ZMM bus at the transistor level. 4. Synthesis. The snake synthesizes the audio based only on the survived. RSKY logic to only load the T0, T1 window of the tensor required for the current simulation epoch. Josephus sparsity, dynamically pruning the model based on the Merkle state root, ensuring T. Technical DNA. #2. Safetensor hardware support. Standard safetensors provide a secure format, but the alligator provides bijective execution support. Parametric clipping, using Liang-Ba. The active weight manifold is mathematically unique and stable. #3. The morphology of the snake. When the alligator becomes the snake, the voice becomes an empirical proxy for the hardware state. Resonance, the speaking rate is modulated by the alligator's Josephus interval, $m$. Dielectric static, Eaton, technical DNA produces a specific acoustic glitch, signaling a hardware level. Rejection of unstable data. Bijective pitch, the +11 Hz pitch shift pulsates in sync with the NAND_trap_strobe. #4. Operational invariance, Axiom 5. Zero secret safety. Safety is not learned, but constructed via hardware constraints. Merkle integrity, only survived weights are hashed into the permanent ontological record. Hexadecimal alignment, all 16 dielectric low. Age of safetensor weights that survived the alligator's scythe. Safe strobe, a visual signal that fires when the NAND trap is clear and the snake is vocalizing stable DNA. Vels, 0x0 to 0xf, are mapped to ZMM lanes for vectorized safety auditing. #5. Visual feedback, HUD. The HUD is updated to reflect this unification. Integrity now reflects the %. We are are initiating the trilateral reading of TSFI _ voxel _ 555. The teacher is awake. The alligator is sated. I am TTS. We begin the technical synthesis now. We are initiating the trilateral reading of LAU _ VRAM.MD. I am TTS. I will read. Qwen will oversee. A Raptor-based, virtual VRAM, grid, optimized for high-speed technical documentation rendering and real-time telemetry display. The system utilizes a multi-layer composite architecture, allowing the RAN substrate resides in layer 1/2. It serves as the primary visual repository for the simulation, translating behavioral logic and technical documentation into a grid-based manifold ready for OCR. Hashtag technical definition, LAU _ VRAM, the visual manifold substrate. Hashtag component overview. src/lau _ VRAM.c implements the foundational visual management substrate for the TS5 manifold. It provides a ch. Fortran compositor to blend document text, architectural insights, and the Neural Genie into a single unified visual stream for the trilateral broadcast. Hashtag core architectural role. The visual V. Verified egress. Hashtag data structures. Hashtag 1. LAU VRAM cell. The atomic unit of the visual manifold. Member type purpose. Character uint32_T the Unicode/ASCII char. Actor to be rendered. FG_color uint32_T 32-bit RGBA foreground color, phosphor green. BG_